Now, I have to discuss previously example of matrix addition and normal matrix addition. Now, this is the matrix addition, normal matrix addition. Matrix multiplication can be used with vectors as well as matrices. Consider the product of a vector of one and then matrix X as Z with six rows of four columns, 6 rows and 4 columns. We see the following example in this slide. Uh, then the sum of each column is found multiplying the matrix by one vector with X, Y, Z. Dividing each of these sums by the number of rows yields the mean for each column. That is find 1 dash X, Y, Z is equal to this equation for the C columns, and then divide by the number of rows. Note that same results found by call means xyz function. তার মানে মেইন ইকুয়েশন ফাংশনটা হচ্ছে call means, column means xyz. Okay. Means for column, we can use the dim function. Dim function for means column, dim function to find how many cases or the number of variables. সেটা আমি dim function দিয়ে জানতে পারি. Dim xyz matrix element. Dim has two elements, dim xyz and number of rows, and dim xyz is number of columns. তার মানে dim দিয়ে কটা কলাম কটা রো আছে সেটার ভ্যালুটা আমি বের করতে পারি. This is the following example of showing the dim function. Dim xyz, একটা রো বেরোবে, কলাম বেরোবে. Okay. Deviation scores. The form of matrix of deviation scores where the elements of each column are deviations from the column mean. Before we discuss the column mean, it is necessary to either do the operation on the transpose of the xyz matrix or to create a matrix of means by pre-multiplying the means vector by a vector of ones and subtracting this formed data matrix. তাহলে mean কমান্ডটা কি হবে, x diff কমান্ড দিয়ে আমি করব x means x diff. Variance and covariances. Variances and covariances are measures of dispersion around the mean. We find this by first subtracting the means from all the observation. This means centered matrix is original matrix minus a vector of means. To make a more interesting data set, randomly order in case sample without replacement from the item in xyz and then find x dot means x dot diff matrix. Okay, x means আর x diff matrix দিয়ে আমি এটা করতে পারি variance and convenience. তারা কিভাবে কাজ করে সেটা নিচের এক্সাম্পলটা সেট সি 42 এইটা দিয়ে 42 দিয়ে তোমরা দেখে নিতে পারো যে কিভাবে এই দুটো ফাংশন কাজ করে. dim and diff আর means. আগে বললাম dim. ওকে, mean, dim, find the column average, diff means diff. Compare this result to just using scale function to mean center the data x in center করছি scale false scaling approach. Clear? To find the variance and compare the matrix, find the matrix product of the mean center matrix x diff with itself divided by an n-1. Compare this result and COV function, COV function. the normal way to find the covariances. The difference between these two results is the rounding to whole numbers for the first and two-dimensional in second. Please see this example. Round curve, column row, round curve দিয়ে এটা করলে আমি এইরকম ভাবে পাবো। Variances and covariances. Some operation need to find just diagonal of the matrix. For instance, the diagonal of the matrix X curve found above constrain the variance of the items. The extract just diagonal or create a matrix with a particular diagonal, we use the diag command, D-I-A-G, diag command. We can convert the convariance matrix X dot curve to a correlation matrix X dot curve by pre and post multiplying the covariance matrix with a diagonal matrix containing the reciprocal of the standard deviation, square roots of the variance, right? Remember that the correlation RXY is the ratio of the covariance, মানে CXY by root এত দিয়ে করলে আমি covariance পাবো square root of the product variance. Please see the following example. Clear? This is the equation. Now, correlation from linear algebra. Correlation টা কিভাবে করা হয়? Compare this the standard command for finding correlation for function টা use করে কিভাবে আমি correlation টা করব, right? তাহলে COR function টা দিন correlation linear algebra correlation function. Eigenvalues and eigenvectors. This is a very vital thing in data science. The eigenvectors of a matrix are said to provide a basis space for the matrix. This is a set of orthogonal vectors which, when multiplied by an appropriate scaling vector of eigenvalues, will be reproduce the matrix. Given n into n matrix, R each eigenvector solves the equation following equation, and the set of eigenvectors are solution to the equation like this second equation, and where here the Ax is a matrix of orthogonal eigenvectors and lambda is a diagonal matrix of eigenvalues eigen and I, then the equation like this. Here eigenvalues and eigenvectors. The function EIGEN raising এই একটা ফাংশন যেটা আরে ইউজ করা হয় ক্যালকুলেটস দ্য আইজেন ভ্যালুস এন্ড আইজেন ভেক্টরস অফ এ সিস্টেমেটিক ম্যাট্রিক্স Sn. আইজেন ভ্যালুটার জন্য EV val is the vector eigen Sn, EV in the vector, the matrix of the corresponding eigenvector and eigenvalues. Okay, for large matrix it is better to avoid computing the eigenvectors if they are not needed by using the expression. The eigenvalue E values, E eigenvalues. Okay, finding the eigenvectors and value is computational tedious but may be done using the eigenfunction. Eigenfunction দিয়ে আমি eigenvalue টা বের করতে function which uses the QR decomposition of the matrix. The vectors making up X are orthogonal means that X is dash is equal to 1, and because they are from the basis space for R, that তখন সেক্ষেত্রে ইকুয়েশনটা R is equal to এই ইকুয়েশন. That is that is, it is possible to recreate the correlation matrix R in terms of orthogonal set of vectors. Orthogonal set of vectors or eigenvector scaled by their associated eigenvalues. Yeah. So today I am discussing the eigenvectors, eigenvalues, and tomorrow I will discuss the unit 3. Please read these documents or PPT or see the video carefully, and any doubts, then please mail me or call me anytime. Yeah.